Hello, welcome back to Physics with Mr. Williams. Today we're going to learn about the conservation of momentum. Okay, so conservation, right? Go back to the conservation of energy. What did the conservation of energy mean? Yes, the amount of energy doesn't change. So conservation of momentum means the amount of momentum doesn't change. Okay, so the momentum I have at the beginning is equal to the momentum I have at the end. Those two things have to be the same. Okay? Now, I kind of want to specify I could have multiple momentums. Just like in energy, how you could have multiple types of energy, you could have multiple momentums. So, one way to show that is to use this symbol. Okay? It's kind of a weird looking symbol. It just means add up all of. Okay? So I'm adding up, I'm finding the sum of the initial momentums, and that will equal the sum of the final momentums. Okay? Another way to write this out is to do something like this. M1 VI plus M2 VI. I will put a plus dot dot dot. So if I have more objects, right, each one of these represents an individual object. If I have more objects, I need to add those. Okay? Is going to be equal to, it's just going to be M1 VF plus M2 VF plus dot dot dot, in case I have more objects. Usually you only need to worry about 2 objects at a time. So just 1, 2, 1, 2. Okay? So there's this idea that how much ever momentum you have isn't going to change throughout this problem. Okay? So let's go ahead and look at this first problem. A 76 kg boater, initially at rest in a stationary 45 kg boat, steps out of the boat onto the dock. If the boater moves out of the boat with a velocity of 2.5 meters per second to the right, what is the final velocity of the boat? So the first thing I'm going to do is separate this out into my 2 objects. Okay? I have 2 objects here. One is going to be the boater, and what is the other object? Yes, the other object is going to be the boat. Okay? So those are my 2 objects in this situation. So I have my boater, and I'm going to make sort of a T diagram here to kind of give the variables for just the boater and the variables I know for the boat. So let's start with some of the easy ones. The boater has a mass of what? Yes. The boater has a mass of 76 kg. The boat, what mass does the boat have? Yeah, the mass of the boat is 45 kg. Okay? Now, the tricky part of this problem is trying to decide where do I want to have my initial, where do I want to have my final. Okay? So, in problems like these, you kind of have to get used to these problems. So, the initial is going to be when the guy is standing in the boat. Okay, so he's in the boat, and all of a sudden he's going to jump out, right? So, before is going to be when he's standing still in the boat, and then after is after he leaves that boat, as he jumps out. Okay? So, what will my initial velocity of the boater be? Remember, this is when he's standing, nothing's happened yet. So if I'm standing still, what's my velocity? Yes, my velocity should be 0. Same, if I'm standing still in the boat, I don't expect the boat to be moving. So the velocity of the boat should also be 0. Now, the velocity, the final velocity of the person is going to be this 2.5 meters per second to the right. Okay? 2.5 to the right. So that's going to be a, well, let's set our axes. So to the right is going to be a positive. Let's make to the left negative. So it's going to be a positive. Okay. Now let's just think about this for a second. What kind of answer do we expect? If I jump out of the boat, which way do I push on the boat? Push on the ground, right, as I'm jumping out. I'm going to push the boat this way, right? I need to push it to the left, okay? So, I expect this to be what? Yes, this final velocity that I'm looking for, I expect this to be negative, because these are going to be in opposite directions. Okay? So now let's go ahead and go to our formula. Okay? So I'm going to start with this. So just like in energy, how we always wrote not that kind of E. EI equals EF, right? Because sometimes they give points just for writing this down. We're going to do the same thing here, because sometimes they give points just for writing that the initial momentum is equal to the final momentum. So let's get that easy point, right? So let's do sum momentum I is equal to the sum of the final momentum, okay? Now, do I have any momentum at the beginning? Well, let's look at it. Do I have any velocity at the beginning? Is anything moving at the beginning? No. If nothing's moving, then what's my initial momentum? Yeah, my initial momentum is 0, okay? Now let's write down our objects, okay? So I have a boater, so that's my green MVF, right? And then I also have my boat. That's going to be my black MVF, okay, right? These are two different objects. Even though I'm sort of using the same variables multiple times, two different objects. Okay, so I got something that looks like this. Let's plug in what we know. We got 0 equals m. The mass of the boater is 76 times 2.5 plus the mass of the boat is 45 times what's the final velocity? Oh yeah, that's what we're looking for, right? Times VF. So I need to subtract this to the other side. So I have 76 times 2.5 equals 45 times VF. I actually made a mistake. When I subtract, I'm going to make this negative, right? Then what's my last step? Yeah, I need to divide by 45. So VF will equal a negative 76 times 2.5 divided by 45. Go ahead and take out of your calculator. See if you can race me and get done before I do. So I got 76 times 2.5 divided by 45. And I get equals 4.22. And it's a negative. Now, let's going back, right? Negative makes sense, right? Because I need them to move in opposite directions. Okay? So you get negative, and then it's just meters per second. Alternatively, I can write it as 4.22 meters per second to the left. Right? Because I need to move in the opposite direction of the boater. Okay? Now let's look at a second question. I'm going to go ahead and erase, and we'll start over. Give me a second as I scroll down. Okay. So, after being struck by a bowling ball, a 1.5 kg bowling pin slides to the right at 3 meters per second and collides head-on with another bowling pin. So let's label this first bowling pin, pin 1, and let's make this second bowling pin, pin 2. So my first bowling pin is moving to the right at 3 meters per second, collides head-on with another bowling pin of 1.5 kg, initially at rest. Find the velocity of the second pin if the first pin moves to the right after the collision at 0.5 meters per second. So let's go ahead and make our T-chart so we can kind of separate out our different pins, our different objects. So pin 1 has a mass of 1.5. Pin 2 also has a mass of what? 1.5. Okay, so I got that. What is the initial velocity of the first pin? Yeah, the initial velocity is going to be 3.0. What's the initial velocity of pin 2? Oops. Yeah, the initial velocity of the second pin is 0, right? Because it starts at rest. Okay? Now I need to find what is the what is the final velocity of the first pin? Yeah, that's my 0.5 meters per second. And what are we looking for in the problem? The final velocity of the second pin. Okay. Now remember, how do we want to start? What do we want to start with? We want to start with our formula. Okay? So I got the sum of my initial momentum is equal to the sum of my final momentum. Now let's write this out. I got two objects, right? So let's do mvi plus mvi equals mvf plus mvf. Okay, so I got something like this, right? Now, this velocity, what is the initial velocity of the second pin? Yeah, it's 0. So this has no momentum initially. I can just throw it away. I don't need to worry about it. So let's go ahead and plug in. I got 1.5 times 3 equals 1.5 times 0.5 plus 1.5 times Vf. What do you notice is the same in every single term? 1.5. So since it's in every single term, I can cancel it out and get rid of it. Therefore, I'm left with just 3 equals 0.5 plus Vf. Just subtract. Vf equals 2.5 meters per second. You notice I actually kind of forgot about my direction. So let's go back. I got left, right, so let's make right positive, left negative. This is positive, positive. That's just 0. So this is also positive. So it's 2.5 meters per second to the right. Okay? So go ahead and look at practice set C. Let's go ahead and see if we can answer this first question. So the first question says, explain in terms of momentum and impulse why it is advisable to place the butt of a rifle, just the back of a rifle, when you're holding a rifle, right, to aim at a target, right, like maybe skeet or whatever. Why do you put it here and not in your face? Like, why wouldn't you put it in your face? Right? So go ahead and see if you can think about that, figure it out. So pause the video, and I'll explain in one moment. Okay, so coming back here. Initially, before you fire, what is the momentum? Nothing's moving, right? What's the momentum? Yeah, it should be 0. Okay, so nothing's moving. Now, the bullet gets shot out very fast, so it has a momentum this way, right? What was my initial momentum? The sum of my initial momentum was 0. So if I add momentum this way, what do I need to also do? I also need to add momentum this way, right? So this is why the gun has that kickback. So if you put it here, it's just going to hit you in the face, right? That's bad. The same thing happens in cannons, right? Think of Pirates of the Caribbean. You fire this cannon, what happens to the cannon? The cannon flies back, right? So anytime you start with something stationary, and I throw something out, you're going to have this recoil, okay? So it's this idea that there's always recoil because my initial momentum is 0. I send something forward, something has to move back, okay? This is the same principle that rockets use, okay? In order to fly a rocket up, I need to send something down fast, right? I need to send chemicals out. I need some sort of chemical reaction. I send something down, and then that propels the rocket up, okay? So this idea of initial momentum being 0 means I need to recoil if I'm sending something forward. Okay? Thanks for joining me on practice set C. I will see you in a moment on practice set D.